Hello everyone, today I'm with you to discuss some of the topics of the vector calculus. So today's topic is solenoidal and irrotational vectors. In the previous videos we have discussed gradient, divergence, curl and related topics. So if you are watching my video first time or if you have not subscribed yet, subscribe this channel to get more updates of my channel and the video I'm going to upload. So let me move to the topic. So let me discuss or define some definitions. So first definition is a vector F is said to be solenoidal if divergence of F is equal to 0. So whenever divergence of any vector is 0, then we call it as solenoidal vector. Similarly, a vector F is said to be irrotational if curl F is equal to 0. So if curl F is 0, then we say that that vector is irrotational. Similarly, we have some other terms or terminology for irrotational. So irrotational vector field is also called as conservative field or potential field. Another very important property of this irrotational is when F is irrotational, there always exists a scalar point function phi such that del phi is equal to F. Then phi is called as scalar potential of F. So whenever we have irrotational vector F, then there exists phi such that del phi is equal to F. So what is this del phi? Del phi means gradient of phi. So when we have irrotational vector F, we can always find scalar point function phi such that F is equal to del phi. Now let me explain some examples related to this topic. Example, show that vector F is equal to xi plus yj divided by x square plus y square is both solenoidal and irrotational. So how to show that any vector is solenoidal? So we have to show that del dot F is equal to 0. So to show that vector is irrotational, so we have to prove that del cross F is equal to 0. We know that a vector F is said to be solenoidal if divergence of F is equal to 0, that is del dot F is equal to 0. So we have to show here del dot F is equal to 0. So what is divergence or del dot F? We have definition. Del means it is dou by dou xi plus dou by dou yj plus dou by dou zk. Dot product with x by x square plus y square plus y by y x square plus y square j plus 0k. So how we get here x by x square plus y square and y by y x square plus y square? That is by splitting this F into component wise. So here xi plus yj divided by x square plus y square. So let me split it as x by x square plus y square plus y by x square plus y square plus 0 by x square plus y square k. So ith component is x by x square plus y square, jth component is y by y x square plus y square, kth component is 0. So let me take the dot product. So this is dou by dou x of x by x square plus y square plus dou by dou y of x by y x square plus y square plus dou by dou z of 0. So dou by dou x of x by x square plus y square we have to find by applying the quotient rule of the differentiation. Even though here partial differentiation, we have to apply the quotient rule. So how to apply? Denominator into, that is x square plus y square into derivative of numerator. So what is the numerator here? X. So what is the partial derivative of x with respect to x? That is 1. So x square plus y square into 1 minus numerator into derivative of denominator. So what is numerator? Numerator is x into derivative of denominator. Denominator is here x square, its derivative is 2x. So x into 2x, which is 2x square. So minus 2x square divided by denominator whole square, that is x square plus y square whole square, plus again we have to apply the quotient rule for dou by dou y of y by x square plus y square, because y is there in the numerator, x square plus y square, y expression is there in the denominator also. So we have to apply the quotient rule for the this differentiation. So again, quotient rule, denominator into, that is x square plus y square, into derivative of numerator. Numerator is here y, its derivative with respect to y is 1. So x square plus y square into 1 minus numerator into, that is y into derivative of denominator. Denominator is x square plus y square. X square is constant here since we are differentiating partially with respect to y. So derivative of y square is 2y. So y into 2y, so which is 2y square. So that is x square plus y square minus 2y square divided by denominator square, that is x square plus y square whole square. Simplifying, so here x square in numerator, x square plus y square minus 2x square, which is y square minus x square. In second numerator, x square plus y square minus 2y square, that is, it is x square minus y square. So adding, we get 0 in the denominator. So this equal to 0. So divergence of vector f, we get it as 0. So we call it as f is solenoidal. Next, we have to prove that f is irrotational also. So we have to show that curl f is equal to 0. So we have to prove that curl f is equal to 0. So use the definition of curl f, that is curl f is equal to del cross f is equal to determinant I, j, k, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. So where f is equal to f1i plus f2j plus f3k. If you take f as f1i plus f2j plus f3k, we will write here in the determinant ijk, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. So here let us substitute f1, f2, f3. So what is f1? f1 is x by x square plus y square, f2 is y by x square plus y square, f3 is 0. Now finding this determinant, so let us expand this with respect to first row. So dou by dou x into, I into dou by dou y into 0, that is 0, minus dou by dou z into y by x square plus y square. Here there is no z term in y by x square plus y square, so this is also 0. So I into 0, which is 0, minus j into, so dou by dou x of 0, which is again 0, minus dou by dou z of x square plus y square. Here there is no z term, therefore dou by dou z of x by x square plus y square is 0. So again it is plus 0j or minus 0j, plus k into dou by dou x of y by x square plus y square. Here we have to differentiate partially, minus dou by dou y of x by x square plus y square. So which is equal to k into this partial derivative, we will get it as minus 2xy by x square plus y square by whole square plus 2xy divided by x square plus y square whole square. To differentiate this one, dou by dou x of y by x square plus y square, you can apply the quotient rule, you will get answer. Here also, to differentiate x by x square plus y square, you can apply the quotient rule. So finally we get it as 0 vector. So curl f is equal to 0. So f is irrotational. Now let me explain another example. Example 2, that is find the value of a and b so that vector v is equal to x plus 2y plus 4zi plus 2ax plus by minus zj plus 4x minus y plus 2zk is both solenoidal and irrotational. So given vector v is both solenoidal as well as irrotational, we have to find the values of constant a and constant b. So how we can find the values of a and b? So we have to use the given property, that is, since this v is irrotational as well as solenoidal, we will use the definition of solenoidal and irrotational, and hence we will find the values of a and b. So let me move. So given v, vector v is solenoidal, so let me start from the solenoidal property. So del dot vector v equal to 0. So here we use the definition. Del means dou by dou xi plus dou by dou yj plus dou by dou zk, dot product with v1i plus v2j plus v3k. So what is v1, v2, v3 here? Given in the vector, v1 is x plus 2y plus 4z, v2 is 2x ax plus by minus z, v3 is 4x minus y plus 2z. So let me substitute. So which is equal to 0 given because it is solenoidal. Now let me find the dot product. Dou by dou x of x plus 2y plus 4z. So how to find dou by dou x of x plus 2y plus 4z? Here x derivative is 1 and derivative of 2y is 0 because we are differentiating partially with respect to x. When we differentiate partially with respect to x, other all variables we have to treat as constant. So here 2 is constant, y is constant, derivative of constant is 0, derivative of 4 is constant, z is constant, so derivative of 4z is 0. So it is 1 plus 0 plus 0. So it is 1 plus dou by dou z, dou y of 2ax plus by minus z. Here only y is variable, derivative of y is b and derivative of 2ax is 0, derivative of minus z is 0. So plus b. Next plus dou by dou z of 4x minus y plus 2z. Here only z is variable, derivative of z is, that is 2z is here, its derivative is 2. 4x is constant since we are partially differentiating with respect to z, and minus y is constant. So derivative of constant is 0. So derivative of 2z is 2. So we get 1 plus b plus 2 equal to 0, which means b equal to minus 3. So we got the value for b. Now we have to find what is a equal to. So by using solenoidal property, we got the value for b. Now to find the value of a, we will use the property of irrotational. So what is irrotational? Vector v is irrotational whenever del cross f v is 0. So use the definition. Del cross v is determinant ijk, dou by dou x, dou by dou y, dou by dou z, v1, v2, v3. Let me substitute the values of v1, v2, v3. v1 is here x plus 2y plus 4z, v2 is 2x plus by minus z, v3 is 4x minus y plus 2z. Since given it is irrotational, so we equate to 0. Now expanding this determinant, I into dou by dou y into 4x minus y plus 2z. Since here y term is there only, minus y, its derivative is minus 1. 4x is 0 because we are differentiating partially with respect to y. 2z's derivative is 0 since differentiating partially with respect to y. So dou by dou y of 4x minus y plus 2z is minus 1. So we return I into minus 1 minus dou by dou z of 2ax plus by minus z. This is also minus 1. So minus 1 minus minus 1, which is minus 1 plus 1, which will be 0 again, minus j into dou by dou x of 4x minus y plus 2z. Derivative of 4x is 4, rest it is 0, minus dou by dou z of x plus 2y plus 4z. Derivative of this is 4 since here only z is variable, other all we are treating constant since differentiating partially with respect to z. So minus j into 4 minus 4, which again will be 0, plus k into dou by dou x of 2ax plus by minus z. Derivative of 2ax is 2a minus dou by dou y of x plus 2y minus 4z. Derivative of x plus 2y plus 4z will be 2. So k into 2a minus 2 is equal to, right side we have 0 or 0 vector. So 0 vector we can write 0i plus 0j plus 0k. Now we know that whenever two vectors are equal, their component coefficients are equal. That is here 0i plus 0j plus k into 2a minus 2. Here right side 0i plus 0j plus 0k. So coefficient of k in the left hand side is 2a minus 2, right hand side is 0. So we can equate it. So 2a minus 2 is 0, hence we get a equal to 1. So finally a value is 1, b value is minus 3. So this is the solution. Now let me explain another example. Show that vector f is y plus zi plus z plus xj plus x plus yk is irrotational. Also find a scalar potential phi such that f is equal to del phi. This is very important question and very interesting property also. So how to start? First we have to show that given vector is irrotational. So to show that given vector is irrotational, we have to prove that so del cross f is 0. So let me start from the definition. So del cross f, that is curl f is equal to 0. So definition is written here, and substitute for f1, f2, f3. What is f1? F1 is y plus z. What is f2? F2 is z plus x. What is x? F3? F3 is x plus y. Let me substitute f1, f2, f3 and expand the determinant. So here I into dou by dou y of x plus y, which is 1, minus dou by dou z of z plus x, which is 1, minus j into dou by dou x of x plus y minus dou by dou z of y plus z, plus k into dou by dou x of z plus x minus dou by dou y of y plus z, which we get I into 1 minus 1 minus j into 1 minus 1 plus k into 1 minus 1, which is vector 0. So thus vector f is irrotational, or we can also call it as conservative. So irrotational vector, otherwise called as conservative vector field. So we can say it as conservative also. So the first part is over, showing f is irrotational. Now we have to find scalar potential. So scalar potential f phi such that f equal to del phi. So our scalar potential phi satisfy the condition f is equal to del phi. We have the expression for f given in the question, and we know what is del, and we have to find the expression for phi. So let me use the definition. So del phi means dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk equal to here given f. Now, so very important point here it is. So since two vectors are equal, one is in the left side, one is in right side, we can equate component wise coefficient. Here right side it is y plus zi, left side it is dou phi by dou x. So we can equate dou phi by dou x to y plus z. Now we know that integration and differentiation are inverse process. So to find expression for phi, it is enough to integrate in the right side. So phi equal to integration of y plus z. With respect to which variable we have to integrate, that is very important point here. So with respect to x, because this derivative term, partial derivative term was dou phi by dou x, differentiation with respect to x. So we have to integrate with respect to x, plus constant. Since it is indefinite integral, we have to add constant. Usually we add constant term as c1 or c, but here let me write it as y1 of y of z, f1 of y comma z, because here we integrate with respect to x. We know that whenever we integrate with respect to one variable, all other variables we are treating as constant. Here all other variable means y and z. So we write constant term as function of y and z, that is we write it as f1 of yz. So phi equal to integration y plus z dx plus f1 of yz. Continuing, phi equal to, we know that y is constant, we have to treat as constant when we integrate with respect to x. So take y outside to the integral, y integral dx plus z is also we have to treat as constant when we integrate with respect to x. So z into integral dx plus f1 of yz. So this is phi is equal to, here integral dx is x, 1y is there, so xy plus integral dx is x, so xz plus f1 of yz. So this is phi equal to xy plus xz plus f1 of yz. Let me mark it as equation 1. So now this is first equation. Now we have second coefficient of j. Look at here, dou phi by dou y. So in the first expression, dou phi by dou y equal to, what is in the right side, z plus x. Let me equate that. So dou phi by dou y equal to z plus x, which means, since we know that differentiation and integration are inverse process, which means phi equal to integral right hand side it, that is integral z plus x dy. Plus, since here we are integrating with respect to y, all other variables we have to treat as constant. So the constant term of this indefinite integral, that is instead of c, we write it as function of x comma z. Y is variable here, so rest variable, that is x and z, we write it as function of x and z. Since already we have given notation f1, so here I use the notation f2 of x comma z. So phi equal to z into integral dy. Let me split integration. So z into dy, because z is constant and dy is only variable here. So z into integral dy plus x is constant, since we integrate with respect to y, x into integral dy plus f2 of xz, which is equal to phi is equal to zy plus xz, xy, zy plus xy plus f2 of xz. Please note this change. This is f2, not f1. Here it is f2 of xz, not f1. Equation 2, it is phi is equal to zy plus xy plus f2 of xz. Please make this note. Next, we'll consider another coefficient of k, that is dou phi by dou z equal to coefficient of k in the right side is x plus y. So dou phi by dou z equal to x plus y. We know that differentiation and integration are inverse process. So phi equal to integration of right side, that is x plus y dz. So which is equal to plus constant of integration, we will write it as f3 of xy, because here z is only variable, rest all are constant. Rest means variable x and y. So phi equal to integration of x plus y dz, we have it is xz plus yz plus f3 of xy. So note it as equation number 3. Equation 1 we have phi equal to xy plus xz plus f1 of yz, equation 1. Equation 2 we have phi equal to zy plus xy plus f2, this is f2 of xz, and equation 3 is phi is equal to xz plus yz plus f3 xy. Now from equation 1 to 3, left side of equation 1 to 3 are same, so obviously right side also should be same. So we have to get an expression for phi. So let me consider either equation 1 or equation 2 or equation 3 and get the expression for functions, either f1 or f2 or f3. So let me choose equation 1 here. So equation 1, what it says, phi is equal to xy plus xz plus f1 of yz. So we have to find an expression for f1 of yz. How we will find? So we have to see equation 2 and equation 3, since all are equal. So do you see any expression which is having only yz term? Yz means need not be y into z, it can be terms in y and z, maybe y square z square or y cube z cube or y z square. It should be terms in terms of y and z. So in equation 2 or equation 3, do you have any term which is having only y and z term? Of course, here explicitly we have yz term is there. It is there in equation 2 as well as equation 3. So we replace in first equation first y1 of yz by y into z. So we get the answer phi equal to xy plus xz plus yz. Or if you consider another equation, let me consider equation 3, that's also fine. No need to consider only equation 1. So how to find a equation in equation 3, f3 of xy? So we have to find f3 of xy in equation 3. So look at equation 2 and equation 1. Do you have any expression which is having only x and y term? X and y need not be x into y only. It can be terms in x and y, maybe x square, y square, xy cube or sin xy, etc. So yes, it is there in first and second equation. We have xy here, directly we have xy term, need not be same in all the problems. So xy, so if you replace f3 of xy as xy, you get phi equal to xz plus yz plus xy. So that is the